Europa is an ice prison, and the longer we study it, the more we realize that the prison wasn't built to keep something out. It was built to keep something in. For decades, this little moon of Jupiter has been quietly climbing the list of the most fascinating objects in our solar system. Past Mars, past Titan, past anything else we thought might be a candidate for life. The reason has nothing to do with what's on its surface. It has everything to do with what's underneath. Hidden beneath a shell of ice miles thick sits a warm, salty, undisturbed ocean that has likely been there since the early days of the solar system. So what happens if you go? What happens if you actually try to set foot on Europa, drill through its skin, and meet whatever has been waiting down there in the dark? The honest answer is that you don't come back. Not because the mission is hard, because Europa is built from its surface to its core to kill you. Let's start with the approach. You are inside a spacecraft roughly 390 million miles from home, give or take 100 million depending on where Earth and Jupiter are in their orbits. The sun, which warms your face on a summer afternoon back home, is now a sharp little point of light barely bigger than a star. You're getting about 1/25th the sunlight Earth gets. Solar panels here are almost useless. Your spacecraft is running on a nuclear power source, slowly bleeding heat into the cold to keep your instruments alive. Outside the window, Jupiter fills your view. Not a pretty marble in the distance. A wall. A bruised, banded, churning wall of gas, big enough to swallow over 1,300 Earths, glowing faintly with its own internal heat. And then there's the radiation. Jupiter is the most violent radiation source in the solar system that isn't a star. Its magnetic field traps and accelerates charged particles into belts so intense they would fry an unshielded human in minutes. Europa sits right inside one of the worst zones. The surface of this moon gets blasted with the radiation equivalent of roughly 540 rem every single day. That's not a long-term concern. That's a lethal dose within 24 hours of exposure. Stand on Europa in a normal spacesuit for one day and the cells in your retinas start to die. Your blood loses the ability to clot. 2 days and your nervous system begins to come apart. A week and there isn't enough of you left to bury. So before your boots ever touch the surface, Jupiter has already started killing you. The lander touches down. The dust around the legs is faint, grey like flour. As the engines cut out and silence rushes in, you take your first real look at the place. Europa is brighter than fresh snow. Its surface reflects more than 5 times the sunlight our own moon does, fierce enough to wash out your visor if you don't dim it. The terrain looks like something a child drew in crayon. 1,000 red-brown cracks running across a perfectly smooth, blinding white plain. Some of those cracks are longer than the entire continental United States, coast to coast. Single, unbroken scars stretching across thousands of miles of frozen sea. The surface itself is the smoothest known solid object in the entire solar system, with almost no craters. Whatever has been hitting Europa over the last 60 million years has been swallowed back up, the ice resurfacing itself the way a wound closes on a body that won't stop healing. The temperature outside your suit is around -260 degrees Fahrenheit. That's about 130 degrees colder than the worst night ever recorded in Antarctica. If your suit's heaters failed, your blood wouldn't get a chance to freeze. You'd hear a sharp crack inside your helmet as the moisture in your breath crystallized, and you'd be unconscious before you understood what had happened. But the cold isn't what's interesting. The ice is. Take a step. The ground sounds different than you expect. Not the crunch of snow, a flat, hollow thunk, like tapping on the side of a giant frozen barrel. Because underneath your boots, the ice isn't just thick. The ice is a planet's worth of frozen ocean. Scientists currently estimate the shell is somewhere between 10 and 15 miles deep, possibly more in places. Imagine the entire height of Mount Everest stacked on itself 2 or 3 times, all of it solid ice, separating you from the water below. And the water below is the whole reason you came. Beneath that shell sits more liquid water than every ocean on Earth combined, twice as much by current estimates. Picture the Atlantic, the Pacific, the Indian, the Arctic, the Southern, all of them poured together, doubled, and then trapped under a lid of ice on a moon smaller than our own. That is what is sitting beneath your feet. We didn't always know it was there. Galileo, the NASA probe that orbited Jupiter from 1995 to 2003, didn't see the ocean directly. It detected the ocean indirectly by watching how Europa disturbed Jupiter's magnetic field. The disturbances only made sense if something electrically conductive was sloshing around inside the moon, and the cleanest explanation was salt water. A lot of it. We were piecing together the existence of an ocean from magnetic ripples decades before we ever got a clear look. So how is it liquid? You're hundreds of millions of miles from the sun. Nothing should be liquid out here. The answer is Jupiter. The same monster that's irradiating your spacecraft is also squeezing this moon like a stress ball. As Europa orbits, Jupiter's enormous gravity pulls it slightly out of shape, then lets it spring back, over and over. That constant flexing generates heat deep inside the moon. Not enough to melt the surface, plenty to melt the inside. Europa is being kneaded alive by the planet it cannot escape. That hidden warmth is the reason there might be something down there with you. Drilling through the ice is the easy part to imagine and the hardest part to actually do. The plan, in concept, sounds simple. You melt your way down. A nuclear-powered probe, called a cryobot in the design papers, sits on the ice and warms itself until it sinks. Above it, the water refreezes. The probe descends through its own private tunnel, a thin tether trailing behind it to keep the surface in contact. Inch by inch, foot by foot, it sinks toward the ocean. The problem is the depth. At a mile down, the pressure on the probe is already crushing. At 5 miles, the ice is so cold it behaves like steel. At 10 miles, the tether has to survive temperatures and stresses no cable on Earth has ever endured. And somewhere in that long, slow descent, the probe might encounter something nobody planned for. A lake of liquid water trapped halfway down. A pocket of brine that conducts heat differently than expected. A sudden shift in the ice that pinches the tether and severs you from your machine forever. The Hubble Space Telescope and the Galileo probe have already shown us that Europa's shell isn't a smooth, uniform lid. It cracks, it shifts. There are places where giant slabs of ice appear to have slid past each other, like tectonic plates on a frozen Earth. And there are plumes, geysers, jets of water vapor erupting from the surface and reaching over 100 miles high before falling back as snow. In 2019, an international team led out of NASA's Goddard Space Flight Center used the Keck Observatory in Hawaii to directly detect water vapor in Europa's thin atmosphere for the first time. Real water, leaking from somewhere below in measurable amounts. If you happen to be standing in the wrong spot when one of those vents fired, your suit and your body would be hit by a hypersonic blast of slush and salt traveling thousands of feet per second. There would be nothing left to recover. Let's assume the drill makes it. Days, maybe weeks of patient melting. The water around the probe goes from solid to slush to dark, salty liquid. Sensors begin to register actual pressure, the kind of pressure you get underwater. And then, finally, the probe drops into open ocean. This is the moment we've been waiting for since the first close-up images came back from Galileo in the 1990s. The pressure at the bottom of Europa's ocean is estimated to be hundreds of times what we experience on Earth's deepest sea floor. The Mariana Trench, the deepest place on our planet, sits at about 7 miles down and produces pressure that would crush a person flat in an instant. Europa's ocean is far deeper than that, and the floor is hotter and the chemistry is alien. Down there, near the rocky core, conditions might look almost familiar. Hydrothermal vents, maybe? Cracks in the ocean floor where hot water laced with minerals seeps up from below. On Earth, those same vents are surrounded by some of the strangest life we've ever found. Giant tube worms with no mouths. Bacteria that eat sulfur and breathe iron. Crabs whiter than paper, blind, clustered around boiling water in temperatures that would cook a human in seconds. Whole ecosystems that don't need the sun, only the chemistry of hot rock meeting cold water. If life exists on Europa, this is where it would be. Not floating near the ice, down at the bottom, in the dark, around the vents. And this is the part that should give you pause. Earth's deep ocean is full of organisms that have evolved without sunlight for tens of millions of years. And they are bizarre. They glow. They produce neurotoxins. They have eyes that don't quite work like ours, or no eyes at all, or rows of sensors that detect electric fields and pressure changes you cannot feel. Europa's ocean has been isolated, in total darkness, with its own chemistry and its own heat source for billions of years longer than that. If anything is alive down there, it has had 4 billion years to become something we have no name for. The probe's light switches on. The beam cuts maybe 60 feet into the black before the water swallows it. Particles drift through the cone of light. Sediment, maybe ice crystals, maybe something else. The probe rotates, slowly, scanning. And on the other side of that thin sheet of glass, the entire history of an alien ocean stares back. You're seeing what no human eye has ever seen, broadcast back through 10 miles of ice to a satellite, then beamed across hundreds of millions of miles of empty space, and arriving on a screen somewhere on Earth. There's a delay of roughly 40 minutes each way between what the probe sees and what mission control on Earth knows about it. In that delay, anything can happen. Now picture the worst case, and there are several. The probe brushes against something solid. The image shifts. A shape moves at the edge of the light, then disappears. The temperature sensor jumps. Pressure spikes. The tether goes slack, then taut, then slack again. Contact is lost. You can sit on Earth and wait the better part of an hour for the next ping. The ping never comes. Whatever happened down there happened in silence, with no witness and no recording and no chance of recovery. Europa keeps its secrets the same way it always has. But let's say none of this happens to a robot. Let's say it's you. A crewed mission to Europa is, on paper, possible. On every other level, it is a slow execution. The radiation alone would kill the crew before they ever reached the ocean. Just getting to Jupiter, descending, drilling, sampling and returning would expose human bodies to years of microgravity, cosmic radiation, and isolation that no astronaut has ever endured. Even on the International Space Station, just a few hundred miles above Earth, astronauts lose bone density, muscle mass, and eyesight after 6 months. Multiply that by 5 or 10 years, and what comes home is not the same person who left. Then there's the surface. If a human ever did step onto Europa, that human would be standing on the most lethal patch of real estate in the solar system that isn't actively on fire. Vacuum above, radiation overhead, cold that turns metal brittle as ceramic, and an ice crust that is constantly being reshaped by stresses we don't fully understand. Pieces of it have probably flipped over, top to bottom in the geological past. Other pieces are sliding right now. A crack the width of the Grand Canyon could open beneath you in an instant, and the only thing waiting beneath it is a fall of several miles into freezing brine. Even surviving Europa long enough to reach the ocean would require an engineering miracle. And the moment you get there, you are the contamination problem. Every microbe on your suit, every flake of skin, every breath of vented air is something that has never existed in this ocean before. If life is found on Europa, we need to know it's Europa's life, not ours. Which is why agencies have spent the entire space age keeping their germs off worlds like this one. A human visit would burn that science down on day one. So whether a robot goes or a person goes, the result is the same. You don't really come back. Either you die, or your equipment dies, or you bring back something that should have stayed where it was, or you ruin the experiment of the millennium by simply being there. And then there's the most uncomfortable possibility, the one nobody quite likes to say out loud. We assume the ocean is empty, or at most, full of microbes. We assume that because the simplest theories are usually the right ones. But the assumption is just that, an assumption. We have never directly sampled an ocean older than ours, on a world with chemistry we barely understand, in a setting we have nothing on Earth to compare to. The honest scientific position is that we have no idea what is in there. Maybe nothing. Maybe a thin soup of single-celled things. Maybe more. Sometimes the smart move in this universe is not to look. Most of the time, we look anyway. If we ever drill through that ice, we are going to learn something that changes everything. Either Europa's ocean is empty, in which case the question of why becomes one of the biggest mysteries in biology, because the conditions look almost perfect for life. Or it isn't empty. And if it isn't, then we will have to sit with the realization that the second example of life in the universe has been hiding just down the hall from us this whole time, locked behind a frozen door, breathing in a sea we cannot survive. You can already feel the pull of it. That's why every major space agency on Earth has Europa on the schedule. NASA's Europa Clipper launched in October 2024 on a SpaceX Falcon Heavy, took a gravity assist past Mars in early 2025, and is now on a long looping path that will put it in orbit around Jupiter in 2030. From there, it will make close to 50 flybys of Europa, ducking in and out of the radiation as quickly as possible, mapping the ice, sniffing the plumes, and looking for the thinnest spots in the shell. The European Space Agency's JUICE mission is heading the same way, on its own slower route, and is set to arrive in the early 2030s. Neither one is going to drill. Both are going to scout. They will tell us if it's worth taking the next, far more dangerous step. It will be worth it. We will go. Sooner or later, somebody is going to send a probe through that ice, and somebody is going to watch a light flicker on, in a place that has been completely dark since before the first cell divided on Earth. The probe will descend. The ocean will accept it, the way an ocean accepts everything. And somewhere in that vast, black, salted dark, something might turn, or stir, or simply continue what it has always been doing, indifferent to the small machine that just dropped into its world. You won't come back from Europa. Not really. Even if your body returns, even if your data makes it home, the version of you that asked the question, "Is there anything down there?" is replaced by a version that has the answer. And once you have that answer, the universe is a different place. Smaller, maybe. Older. Less alone. A moon nobody could see with the naked eye for most of human history is going to be the moon that decides what we are. the only company in the universe, or one neighbor among many, hiding under the ice of a world too cruel for us to ever truly visit. Europa doesn't care which one is true. It's been keeping the answer for 4 billion years, and it can keep it a little longer. Thanks for watching, and I'll see you in the next one.